All right. 27th of March, 2026. We go back to easy problems. That's what we like to see. All right. 2946 matrix similarity after cyclic shifts. You're given m by n integer matrix and an integer k. The matrix rows are zero indexed. The following process happens k times. Even indexed rows are shifted cyclically to the left. Odd indexed rows are shifted cyclically to the right. Return true if the final modified array... Oh my goodness. Return true if the final modified matrix after k steps is identical to the original matrix, and return false otherwise. Okay. So, yes, I think I understand the idea, but let me look at things. So, if we look at the first one, k equals 4 means the even rows, 0, 2, so these ones, will shift to the left, it said, right? So it'll be like, you shift to the left, and then shift to the left again to make 3 at the front, then 1 shifts again, and then 2. So because we have 3 columns, and we're shifting 4 times, we essentially just shifted once, right? We might as well have just shifted once to the left. And then similarly, shift to the right once, twice, thrice, and then 4 times, which again, we might as well just shifted once because we only have 3 columns anyway. And then 7 back to 3, 4. So yeah, so as you can see, the fourth, the k equals 4 matrix versus k equals 1 matrix is identical, which makes sense because if you're going to have 3 columns, shifting by 3 will make you identical, right? Like you might as well have not done anything. So I think it does make sense to mod k by number of columns, but we'll just keep that in the back locker. So in this case, we only shifted twice, even though there's 4 columns. So you would expect, the matrix not to sort of repeat itself. However, because the phase, it's like the pattern in the columns is that you go 1, 2, 1, 2. So you're able to see like after 2 cycles, you're able to see 1, 2, 1, 2 again. 5, 5, 5, 5, same kind of idea. And 6, 3, 6, 3 makes 6, 3, 6, 3. So it makes sense that you're able to see, the same matrix again, even though you only do 2 iterations. And then this is true because I guess you only have 2, because it's 2, 2. Okay, it doesn't matter how many times you rotate for a 2, 2, 2, 2. Like it's always going to look like 2, 2. So that's fine. So I'm assuming the reason why this is considered an easy problem is because the constraints are small. So you could brute force everything, which we might do if I'm really struggling to think of a cleaner thing. But I do believe... Oh, no. Let's start with the brute force solution because I feel like sometimes I try to overdo it and then I end up looking like a fool. So we'll start with the most simple solution, which is just to shift everything manually and then comparing. Matrix similarity after cyclic shifts. So the major notes to remember is even indexed rows shift left, odd indexed rows shift right. Things we've observed is like k mod num columns is a good idea. And I mean, that's pretty much it. Hang on. Let me just try to check one thing. Let's say you have like, I didn't write constraints. Hang on. Let me write the constraints first. So number of rows is between 1 and 25. So number of rows is between 1 and 25. Number of columns is the same. number of columns is between 1 and 25. K itself is between 1 and 50, but we will reduce K down to be mod, it's going to be between 1 and 25 again because we're going to mod it. So that's fun. The actual values themselves don't really matter, but they go up to 25. Now, what I'm thinking, right, is let's say in this position, K is equal to 3. In my mind, in order for this, if we consider the first row, right, shifting to the the 0th row, shifting to the left. If it's like 1, 2, 3, 1, 2 or something, right? And I shift this 3 times, 2, 3. Like the 3 is going to get over there, and a 1 is going to get over here. Like it's definitely not going to work, right? In comparison, if we had 6 columns, 2, 3, 4, 5, and 6, and we had like 1, 2, 3, 1, 2, 3 with K equals 3, because like you have a consistent phase of size 3, like this, where the phase size is equal to the K equals the K value, then when you shift it down 3 times, this 3 will go from here, 1, 2 to here. This 2 will go to here. This 1 will go to here, and this 3 will go to here, 1, 2, 3. And like this 2 will go 1, 2, 3. The 1 will go 1, 2, 3. So in my mind, what I'm thinking is, so for each row, if the phase size, where phase refers to a repeating sequence, is if you have an equal phase, then you're pretty much solid. I'm trying to think, but for example, right? Let's say you have like the same number over and over again. 1, 1, 1, 1, 1. This would also work because it's all ones, right? So I'm trying to figure out if those are the only 2 ways this would work. Like either K equals 0. This is after the mod. So after K mod numcols, either K equals 0, the entire row is one number, like this, or the phase size of the row is equal to K. I think what I'm trying to get at is I think these are like the criteria. One of these 3 conditions have to be true in order for the row to successfully sort of shift back into position after K shifts, I think. And honestly, the fact that these ones get shifted left and these ones get shifted right, I want to say doesn't matter, but I could be wrong. I'm a bit nervous to say that. Is there any reason why shifting left versus shifting right would make a difference? I'm not sure. I don't think so. I can't imagine what it would be, but I don't think it would, because like the idea is you're trying to return back to the same position. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Like if you wanted the 3 to return back to its same position, like exactly the same position here, then you have to do 6 regardless of which way you go. If you go, left or right, you'd either have to go 1, 2, 3, 4, 5, 6, or you'd have to go 1, 2, 3, 4, 5, 6, right? Like it's about the length of the row, like how many columns are in the row. But then, why would it matter? Like I don't think the direction matters. I feel like it's a misdirect, but I'm worried that I'm missing something, but I don't know what it is. Especially after yesterday where I missed a case. 6. Let's put 1 more. So let's say K equals 2. 1, 2. Is there any way I could not have a same phase over and over again? I don't think so, right? Because like even if you have some kind of pattern, let me get rid of that last column actually. Like if you have any other pattern, 1, 2, 3, 2, 1, 2, maybe 3, 2. I'll do one more. If you only shift twice to the left or right, like the 1, the 3 is going to take a 1's place and the 1's going to take a 3 place, right? It's not going to look identical. Same if you go this way. The 1 will take a 3 place, the 3 will take a 1. So I think this is true. I did just say I would brute force it first so that I, had a thing to a foundation to stand on, but I'm abandoning that idea because I am going all in on this criteria. Either k equals 0 after the mod, of course, after the mod k equals 0, or the entire row is just one number, right? If it's all ones, it doesn't matter. No matter where you shift it, it will be the same, regardless of direction as well. Or the phase size of the row is equal to k. So all we have to do there is take a window of size k and say, what are the numbers? And then take the window of this, of size k, of the next 3 numbers and say, what are the numbers? Are those the same? Yes, then keep going. Are those the same? Yes, then keep going. Are those the same? Maybe no, then in which case, okay, this is going to fail. And as soon as the phase size is wrong and the numbers aren't the same and the k isn't 0, we can say this whole matrix is going to fail. And I genuinely do not think shift direction matters. I'm saying it here. I'm saying it now. I can't think of a case at the moment where shift direction would make a difference. Maybe I'm wrong. I wouldn't be surprised because I feel like it's such a strange detail to add. Why is this important? I feel like it should be important, but I can't think why. Because the idea is you're trying to shift it back to... You have to shift it so that it looks the same. But if the phase condition holds, then it doesn't matter. Oops, that's the wrong thing. If the phase condition holds, it doesn't matter which way you go. It will look the same. If you shift 3 this way or shift 3 the other way, it will look identical. The direction shouldn't matter. If it's all the same number, direction wouldn't matter. If k equals 0, direction doesn't matter. Is there any other conditions I can think of? No. Because in order for it to look the same, either there has to be like another 3 to reach, right? Like another 3, 1, 2, 3, 1, 2, 3. There needs to be a 3 you can reach. I think I'm right. I don't know. I think these are the 3 conditions I want. Okay, so let's just code it up as is, and then if it's wrong, then it's wrong. But I don't know. So num rows, as usual, num rows equals the length of mat. Num cols is equal to the length of mat at 0. So k is equal to mod equals num cols, right? Wait, I just had a thought. I just realized something. As I modded, I had a reason. Okay. If you have 1, 2, 3 and k equals 1 and you shift to the right, then you get 3, 3, 1, 2, right? But if you shift to the left, then you get 3 in the middle with a 2 here and a 1 here. So you do get a different output, right? However, my point, I think, still stands. The direction is important because we don't have the phase condition. If the phase condition holds, then the direction shouldn't matter. And if the phase condition doesn't hold, then it doesn't matter which direction you go in. It's never going to work. So the direction of shifting is important in the sense that you get a different result, right? You'll get a different result. But in terms of the check for if you get the same matrix back, I don't think it matters. So basically, I haven't actually changed my mind on anything, and that was a complete waste of time. But direction does matter in the sense that you get a different output for a row, But if your goal is to make the output look the same as the input, you would have to shift by a k number of times in either direction anyway. So I think this still holds. Okay, let's go for it. If k equals 0, return true straight away. Otherwise, for r in range num rows, or maybe I can just say for r in grid, will I need... we'll see. For c in range... Do I want the number, or do I just want the... For val in... So if this is like each value in the row. If I'll do it separately. Okay, so we have two conditions. So we check the k equals 0 condition, that's done. Now we have to check if the entire row is one number. So uniform equals true, and phase equals true as well. So these are the two conditions, the uniform condition and the phase condition. So the uniform condition says, the entire row is one number. If for val in R1 onwards, so we'll say the row val is equal to R at 0, right? If what am I doing? If val is equal to row val, if val is not equal to row val, then the uniform condition is equal to false, and we can break out because that's all I wanted. Now we have the window size, so window left is equal to 0, window right is equal to window right is equal to okay, -1? Yes, because I want the size to be k. Now, first things first, I think if number of columns is like not divisible by k, then I don't think you can have a phase anyway. Like, for example, if, let's say, the number of columns is 3, sorry, the number of columns is 3, but k is equal to 2, then your phase has to be of size 2, but you have 3 columns. So I don't know if that's ever going to work. Like, if you have 1, 2, that's going to fail for sure, because this 2 is going to be shifted either 1, 2, or it's going to be shifted 1, 2, in which case this guy has to be a 2, but this guy would shift 1, 2 and hit the 1. So I think if the number of columns is not divisible by k, by the window size, then you immediately know that the phase condition is false, and I honestly think you can break out... No, don't break. Else we'll do this. This is getting a bit dusty, but anyway. While r is less than num col, so while it's a valid index, we're going to have to increment L by, well, L should equal R plus 1, and R should equal L plus K minus 1 to give us to maintain a window size of K. How do I want to do this? I think I just say window is equal to the row R from 0 up to k. So that's going to take the first k elements. Can I just say if So if I'm doing that, then I can make this like this. I can make this equal to k, and this equal to L plus k minus 1. If window is not equal to it's not equal to R, I don't want to call it R. I don't like. Oh wait, I have R. Oh my goodness. Hang on. I didn't even realize. This should say current row. That's better. See, I try to be clever with the. I try to be all competitive with the naming, and look what happened. See, now I'm confused. This is current row. Okay, so I first introduce R here. So while the R index, so current row at this L value and at this R value plus 1. Honestly, I could probably just say L plus K. And then I don't need the plus 1 here. I can just say, because remember, this is exclusive, and same thing here. So L equals plus K, and then it should equal R, because this is the exclusive index, not the inclusive index. If they're not the same, then you can immediately set the phase condition to false, and you can break out. All right. And then the idea is, if both conditions failed, if not uniform and not phase, that should be a phase, not phase, phase, then return false. And if you go through all those rows and you manage to return, like you manage to keep something true, either wait, not return, true. Either the uniform condition is true or the phase condition is true. I guess no. I was going to say the uniform condition will hold true because... Okay. And then if we go through all that and nothing bad happens, I think we could... I should have brute force first. I regret my decision making. But I just think I'm right. As in, like, in what world, if the phase size is not... If the phase condition doesn't hold, in what world could it still work? None, right? Like... If the phase condition where like k equals some k, for some size k, you have a repeated sequence of k elements over and over again, that's the phase condition. Phase condition is true if every k elements looks the same, basically. Like that, 1, 2, 3, 1, 2, 3 for k equals 3. In what world does that not work? In what world could you have it where it should return true, but the phase condition is false, and the uniform condition is false? I don't think there is any world. I only really need to do the phase condition. If k equals 1, I don't have to do the phase condition because the uniform condition covers it, but it's fine. Oh, yeah, we'll do that actually. If k is equal to 1, then the phase condition is equal to the uniform condition because they're identical. If it's not thing, if it's not, k doesn't go well into num-calls, then phase should be false immediately. Else this. And so if the uniform condition didn't hold and the phase condition didn't hold, alright, look, either I've done it, I've managed to do this easy. Oh, it's not called grid. Oh, how many times did I say grid? Once. Okay, good. Either I've done it and that's fine, I've managed to achieve an easy problem, or I haven't and there's some interesting edge case that I missed. Maybe it's not even an edge case, maybe I'm just dumb. But let's just understand, alright, that I didn't brute force. Do I want to do some test cases? Let me just try some rows. 1, 1, 1, 1, 2, 2, 2. Alright, so that's what I really care about. And the thing is 4. 1, 2. So like there's 1, 4, but then there's this one. Wait a minute. So my thing would return true in this position, right? Because it's got a phase of 4. But should it? I think I have a blunder. I knew it. I knew it. I'm not... Yeah. There we go. I just had to type it instead of write it, and I found one. So this is wrong because this guy gets to here. This guy gets to here. Wait, no, this isn't what... No, wait, what? Why this... Wait, no, wait. No, I actually misunderstood my own... I'm supposed to say that this guy should equal... If for the phase condition to hold true, this guy should equal this guy. Wait, why didn't my thing return true? Window should look like 1, 1, 1, 1. And then the idea is phase should have been set to false. It's not uniform, and the phase condition should have been set to false. I'm actually confused now. Why did it fail? Okay, so the window is that. Let me first print... Maybe this comparison is not fair. I thought you could do this, but maybe it's not. Maybe it's not right. Ooh. Oh, less than or equal to. Yes, because it's the exclusive index. See, I made a change and it blew everything up in my face. Okay, you know what? I caught a bug, actually. I didn't catch a lack in logic. I did catch a bug, though. That should be less than or equal to. By complete accident, I caught a bug. And I think it's right. I think it's right. No! No! Wait, what? I thought my thing would return true too often. I didn't think it would return false. Okay, so this one, the uniform thing holds true. 1, 2, 3, 4. Oh, so this is what... See, there was a thing. So this one, it would have said the uniform thing is false, but 1, 2, 3, 4... Yeah. Oh, that's what it was. 1, 2, 3, 4, 1, 2... 1, 2, 3, 4, 1, 2. So yeah, it would have said, oh, this doesn't work because the K value doesn't fit. But if the... Okay. So I think if the smallest... If there exists a phase size that is somehow divisible by the... if there exists a phase size that is divisible by the K value... So like in this case, the phase size is 2. Phase size is 1, right? Like the uniform condition. This is 2. Yeah. I knew there was something. I just couldn't clock what it was. I was actually, yeah. Okay. So, is there any... Yeah, so me basically saying, oh, if it's not divisible, if it's not... This was bad. So what I have to do is I have to look for repeating sequences. Again, the brute force option is there. And I think that's what makes it an easy problem, because you could brute force it and it would work because the things are small. But I'm turning it into what I would consider a bit of more of a medium question, because I don't want to brute force it. I think you can do this cleanly. So let's take 5, 3, 5, 3, 5, 3 as an example, right? So 5, 3, 5, 3, 5, 3. And let's say, yeah, K is equal to 4. So we're asking, okay, what is this? Is it the smallest? Because what if the smallest is it possible to have like a phase size of 3 and a phase size of 4? 5, 3, 3, 5, 3, 3. I don't think so. I think, yeah, if your smallest phase size, if your smallest phase size is divisible by goes into K, then I think you're okay. I think it'll work. So how do I realize that 5, 3 repeats enough times to be the phase size? I see the 5, and I go, oh, there's a 3, which doesn't match the current window, so I expand the window, and then I see 5, 3, 5, 3, 5, 3. So what if I see like 5, 3, and then I see like 5, 1, in which case 5, 1 should become, like, this entire thing should become the window, right? 5, 3, and then, oh, 5 matches. That's interesting. This becomes the window. This is not a window. But what if 5, 3, 5 is a window? This is starting to feel a bit like, what's it called? KMP or whatever? Like the thing where it's like you're looking for sort of, yeah, like earliest prefix, like longest prefix or something. I don't know, actually. Could you use that algorithm? Do I want to just do brute force it? Maybe I will. 5, 3, 5, 3. What is that? What is that thing? It's like normally like for palindromes or something, isn't it? It's like, is that right? It's like you're looking for a particular thing, and you ask, are you a prefix? And you're yes. Longest prefix. It's like what? It's like no, you're not a long. And then it's like yes, I am. And yes, I am. And if I see another 5, 3, what would I say? I would say 3, 4. I guess what I'm really doing, you know what? I think I'm overcomplicating it. All I have to do really, considering that in that example, hang on, considering that that example, like I can predict that this 3, which is shifted to the left, is it left? Yeah. This 3, which is shifted to the left, is going to appear, oh, maybe I'll look at the 5. This 5, which is being shifted to the right, is going to appear here. And this 5 is going to appear here. So all I have to do is really just check that all these values are the same. And I just do that for like all the positions. You know what I mean? Like from the range, like if k is 4, right? So for 0, 1, 2, and 3, I just have to make sure like that they all appear in the same, like 1, 2, 3, 1, 2, 3, 4. 1, 2. I just have to make sure that the position they're at versus the position they're going to has the same value. And then if that's, yeah, we'll just do it like that. Which is, I guess it's, yeah, that's like, yeah, it's like taking the brute force solution and making it good. I don't know. I feel like, maybe I should have brute forced. I probably would have seen that quicker if I just brute forced. So if we'll just have like a flag, going left equals true if current row mod 2 is equal to 1, then going left is equal to false. Just a flag. Is that right? Let me just double check. So you left shift if it's an even index, and if it's an odd shift, then you're going right. So yeah, okay, we'll do that. If current row mod 2 is equal to 1, going left is equal to false. And then basically I guess I will need the indices. So for C in range num cols, right? So C is referring to the current column. If C, if going left, so target position is equal to C, I think minus K, and then we'll mod by num cols, which should give me a positive number because the divisor thing is positive. So in this case, I'm pretending we're going left straight away. So in this case, if I take like this example where k equals to 4, or k equals to 1, sorry, I would say 0, 1, 2 as my column, and I'm subtracting 1. I'm subtracting because I'm going to the left, and I'm modding because, for example, if I'm here and I get to -1, I should mod by 3 to go back to 2. You know? Okay. If going left is false, so if we're actually going right, then target position should be with a plus, not a minus. And then if the column, if grid at, no, if the current row, because I have the row already, if the current row at C is not equal to the current row at the target position, then return false. And if you go through all of that and nothing bad happens, then I think you can happily return true. And this is basically O of Mn anyway, right? Because like checking for each column, like within a row, for each column, you do a quick check. You do an O1 check. Whoops. We'll enumerate real quick. Because obviously, all right, I think I back it. This feels more like clean. The other one, I had holes. Like I didn't actually have proof that it was going to work. It is slow though. Interesting. Okay, so we got a baseline, right? Like this is kind of like brute forcey kind of thing, without actually doing the physical shifts. I guess in my mind you would do the physical shifts for like the real brute force, but so I've done something a bit better than that. But there is a way to cut the runtime down. Do I want to waste time? Not really. It's already 7:30, so I think I'll just read it. Wow. Fair enough. So yeah, you mod it. If not K, so if it's 0, yeah, so that's the first condition. That's this guy. For I in range n, rho is equal to mat I and then -1 to the power of I. So that's saying basically this is your way of like deciding whether or not you should be going left or right. Because if it's minus, if it's an even number, then this will become 1. So it's 1 times k plus wait, what? Are they? Oh wait, I think they are doing the shifts. They're literally just doing the moves. Mat I -1 to the power of I times k. Like, I'm tripping out. What is happening? They're taking... Oh no, it's just, sorry. I thought they were just indexing, but they're not. They're taking the full-on, like... what's it called? Like the the splice? Sub-slice? Sub-array? So, let me look at this one. So from the index, -1 or +1 times k. So either minus k, which would be like the last k elements, or positive k, which is like from index k up to the end, plus, what does it mean to add 2 rows? It would be like appending, right? Does this work? -1 to the power of... So same kind of deal. You take that particular row, you take a particular row, you take... So for let's say I is 0, right? So we're we got positive lot of k. So from index k to the end of that row, so columns k up to m minus 1. Take those columns and you bring them to the front, because that's like this. That's the first thing, and then you're adding. I guess it does kind of do the shifting, doesn't it? because you go from this up to that value. This is the same value. So you're taking those, it's almost like you're doing a swap at k. Does that work? Like, for example, let's say 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6, right? Yeah. Let me, and then so it's like 1, 2, 3, 4. Let's say k equals to 4. And then I'll like separate these two. My understanding is what you're basically doing, if we assume that I is even, so like it's an even row, then my understanding is you're taking index k, 0, 1, 2, 3, and 4. You're taking the values after the first k elements, and you're putting them to the front. And you're taking index 0 up to, you know, k in this case, for even, and you're going like this. So what did we do? I think we basically shifted. Yeah, you shifted to the left by 4 by doing that. Because you traversed this guy, you basically took this element, and you knew that this element would be the head of the list. 1, 2, 3, 4. Because you skipped 4 guys and went to this guy. So you just put him to the front. And these guys, you knew would come after, so you just crossed them around. That's quite cool, actually. And then, in a similar vein, if you have, I guess, the first 2 elements, I would assume, and then the last 4 elements, and you have an odd row, so you're shifting to the right, you know that should be 1, 2, 3, 4, and you know that this dude would become 1, 2. Oh, I think I put too many columns. 1, 2, 1, 2, 3, 4. Sorry. I put too many columns. So, this dude, by shifting to the right, will become the new head. 1, 2, 3, 4, right? The head. So it makes sense to swap them around. So you extract this dude, which is index, I guess minus k, minus 1, minus 2, minus 3, minus 4, yeah. Minus k up to the end, take that guy, and then take 0 up to this value, but not including. And swap them. Wow, that's quite cool. I don't think I would have thought of that myself. It makes sense. Having it written out, it does make a lot of sense, but I think the way I thought of it was probably the way I was only ever gonna, like, it's nice. I think my goal was to avoid explicitly rewriting the row, but this is actually quite a nice way of doing it. I'm a little bit surprised my way is slow. I don't know, for some reason, I don't really do any memory allocations, do I? I do a lot of modding, I suppose. That can be annoying. But so do they, surely. Nope, never mind. Alright, fair enough. I respect it.